right, these next two sections I'm actually going to do together and then assign the homework together because they kind of teach both at once and it makes more sense to kind of understand it together. We're going to be talking about mutually inclusive and mutually exclusive events. So I'm going to kind of talk about them separately. Let's talk about exclusive first. And we're going to contrast them with inclusive events. All right, exclusive events are events where they have no outcomes in common. For example, if I'm looking back at my flipping a coin example that I did before, I could say that my options are heads and tails, and there's not something that they ever overlap with those possible things that can happen. And I can write a mutually exclusive event as the probability that I flip a heads plus the probability that I flip a tails is going to be equal to 1, because if I add up both of these events, it's 100%. If my probability of flipping a heads or a tails is 100% because those are the only outcomes I can get, and that's how I know that they are mutually exclusive. Or I can even look at a dice. And if I said that, what is the odds of rolling a 1 or a 2? And I can say that, well, these are mutually exclusive. I can roll a 1 or a 2, and those will never overlap. And the probability of rolling a 1, I can add them together, the probability of a 2. And I can know this I can look at this mathematically. Probability of rolling a 1 is, of course, 1 in 6, plus probability of rolling a 2 is 1 in 6, and the sum of those is 2/6, or 1/3. So the probability of these exclusive events, all I need to do is add them up totally and kind of look at how they work. But I have to remember there is no overlay between these things. Now, inclusive events are different, and I want to look at what their definition is so that I can write it. They have one or more outcomes in common. For example, in this case, I'm going to look at this spinner. My spinner looks like this. And I have a red side, and I have a yellow side. And I also have some words written in. This one says top. This one says top. This one says bottom. This one says bottom. And I want to know, what are the odds of rolling, or if I'm spinning a red and a top? Oh, sorry, red or a top. So I get a red answer or I get a top answer. And I want to know how I can look at this and how I can solve it mathematically. Well, the way that this works is what we do is we add up the probabilities of each. Then subtract the probabilities of both. Let me show you what I mean. In this example, I can write that the probability of red plus the probability of top. So I'm looking for one of these two things happening. So, and I write this, I add the two together, and then I subtract the probability of red and top. And this is going to give me the true probability for a mutually inclusive event. For example, it looks like this. My probability of red, we can see, is 2 out of 4. My probability of rolling spinning a top is 2 out of 4. And my probability of spinning a red and a top is 1 out of 4. And if I do my math here, I get 4 out of 4 minus 1/4 is 3/4. And my answer here is 3/4, or if I write it as a percentage, which I like to do, I can write this as 75%. And that's exactly what I should expect by looking at something complicated like this. I can see that red or top would be 1, 2, 3 out of my total of 4 options. But it gets more difficult when we look at more complicated events. I think we can understand these exclusive events because we've talked about them, but let's look at a more complicated inclusive event and see how we can solve them. Okay, let's look at example 1. And in this case, I'm going to be looking for the probability that a number cube will land up as a 2 or even. A dice is 2 or even. All right, so my formula that I should use for this is my probability of event 1 plus my probability of event 2 minus the probability of event 1 and event 2. And this is going to give me my total probability. So all I'm going to do is put these things in and solve. Okay, my probability that I'm going to roll a 2 on a dice is 1 in 6, because there's 6 outcomes and there's only 1 2. My probability that I'm going to roll an even number is 3 out of 6. I could write this as 1/2, but I know I'm going to have to add or subtract later, so I might as well leave the denominator the same. And I'm going to subtract the probability that I roll. What is the odds of rolling a 2 and a 6 together? Well, that is, quite simply, 1 out of 6 as well, because there is only one way to do both of those things. 1 out of 6, because my 2 and my even overlay. So my answer here is 1/6 plus 3/6 minus 1/6, 1/6. So I get 3/6 again, which is 1/2, which is 50%. Which makes sense because dice is 2 or even. I can really just say that as even, and I know the probability of rolling an even number because, well, it's 3 out of 6. All right, that should make enough sense. I hope if you get stuck, ask a friend, ask me, and good luck.